Hello students, you all are knowing that today we are going to discuss about one important topic, that is Davisson and Germer experiment, as I have written on the board, and I have drawn the experimental setup of the Davisson and Germer experiment. Since we were discussing about the photoelectric effect and you all are familiar that we have discussed that de Broglie was a scientist who has explained about the quanta or photon property of the light, and he has explained that light is traveling in the form of quanta or photon, and he has also explained that the light has a dual nature, means it is showing the nature of wave with the nature of particle, means particle and wave nature both it is showing, means he has explained about the dual nature of light. Who was the scientist? De Broglie, and in 1924 he has explained it, and he has given an idea, and that wave, in which wave the particle is traveling like this, means the light is showing the dual nature particle with the wave, and that is known as matter wave. Matter wave we have discussed in our previous video lectures. Now today we are going to explain it, means the de Broglie was scientist in 1924. He has explained about the matter wave, means the dual nature, but he has not given any experimental proof for this. So after that the scientist came in 1927, the two scientists came, Davisson and Germer, and they have given experimental proof to this experiment. And not only the Davisson and Germer has given the experimental proof to the de Broglie matter wave, de Broglie assumption, one more scientist, G.P. Thomson, was a scientist who has also given its experimental proof, and for this the G.P. Thomson and the Davisson and Germer combinedly won the Nobel Prize in year 1937 for this experiment. So but today we are going to discuss about only not G.P. Thomson experiment. Today in our syllabus, the experiment of the Davisson and Germer experiment of the electron diffraction. So we are going to discuss about the Davisson and Germer experiment of the electron diffraction today, and which will satisfy and which will give an important means support to the de Broglie matter wave. Okay, so you can see I have drawn a setup. You can see that it is an electron gun in which the filament will heat. Here I have connected a battery in which I am showing that 54 volt. Why 54 volt I will explain. Now here is, you can see one rheostat is there by which we can change our voltage. When the filament of the electron gun will heat, then the emission of electrons will start. Electron gun working you have studied in your smaller class 10th, and means in cathode ray tube the electron guns are used. So when its filament will heat, so the electrons will emit from it, and when the electrons will emit, here you can see that we have kept a nickel crystal. Nickel crystal is for what purpose? Nickel crystal is kept here that when the light ray or the electrons will emit and comes on the nickel crystal, then it will reflect. After the reflection, it will go inside the detector. Here is a detector. It will detect the nature or the intensity of the light ray or the electron emitted from there, and this detector is connected in a galvanometer. Galvanometer is used to measure on a circular scale. It will measure the intensity of the light or the intensity of the emitted electrons. So this is the experimental setup of the Davisson and Germer experiment. Now how we will satisfy that with this experimental setup that the Davisson and Germer was correct, that yes, the light has a dual nature. So how we can prove it? So we can prove it that you all are knowing that on the different voltage the Davisson and Germer have done this experiment, means इन लोगों ने अलग अलग वोल्टेज प्रोवाइड किया और अलग अलग वोल्टेज के लिए यहाँ पे इन लोगों ने करंट को गैल्वेनोमीटर के हेल्प से मेजर किया. कभी 44 वोल्ट, कभी 48 वोल्ट, 50 वोल्ट, 54 वोल्ट, 58 वोल्ट, लाइक दिस दे हैव चेंज द वोल्टेज विद द हेल्प ऑफ द रियोस्टेट. बट 54 वोल्ट वो वोल्टेज था. ऑन दैट वोल्टेज दे हैव गॉट द इंटेंसिटी ऑफ लाइट मोर or most, means 54 volt was the voltage on which they have got the better result, means the intensity of light was maximum here at the 54 volt. Okay, so on that they have done this experiment. So how we will satisfy this? And nickel crystal, when the electrons will emit, then the Davisson and Germer was rotating the nickel crystal. इन लोगों ने निकल क्रिस्टल को रोटेट करना स्टार्ट किया. पहले ये ऐसे था, फिर इसको ऐसे ऐसे स्लोली एंड ग्रेजुअली दे हैव स्टार्ट रोटेटिंग, और यहाँ पे अलग अलग एंगल्स पे इसका रिफ्लेक्शन कराया. जैसे पहले अगर ये ऐसे था तो यहाँ से आने के बाद इस एंगल पे जा रहा था, थोड़ा और फोल्ड किया ऐसे ऐसे, और इस एंगल्स को इन लोगों ने डिटेक्टर के चेंज किया. और इस इलेक्ट्रॉन क्रिस्टल्स के अंदर छोटे छोटे एटम्स हैं इस क्रिस्टल के, जो कि एक लैटिस लेयर बना के इसके अंदर अरेंज्ड रहते हैं, जिन पे आने के बाद इलेक्ट्रॉन्स का रिफ्लेक्शन होता है. और इन लोगों ने जब डिफरेंट डिफरेंट एंगल्स पे इसको चेंज करके देखा, तो वो कौन सा एंगल था जहां पे इन लोगों ने देखा कि द intensity of the light was maximum, then that angle was the 50 degree. At 50 degree they have seen that the intensity of light was become maximum. If this is the 50 degree, then in that case this angle was what? Here you can see these lattice layer I have made here also. So these are the lattice layer I have arranged. You can see one more diagram. Inside the nickel crystal like this the atoms was arranged, and these are the layers. That layers are known as the Bragg's plane. Means this internal arrangement was explained in a Bragg experiment or the Bragg law you have listened. And according to the Bragg law, the formula of Bragg law is n lambda is equal to d sine theta. This is what Bragg's law. N lambda is equal to d sine theta, not d sine theta, it is 2d sine theta. And on 50 degree you can see that on the first layer one ray is going, and from the second layer one ray is going. तो ये सारी रेज जो हैं एक वेव के फॉर्म में आ रहे हैं. देन दे विल पास ऑल्सो इन द फॉर्म ऑफ वेव. लेकिन कहीं पे ये ऐसा होगा कि जब ये दो वेव्स निकलेंगी तो कहीं तो इनका इंटरफेरेंस होगा, और जहां पे इन दोनों का इंटरफेरेंस कंस्ट्रक्टिव इंटरफेरेंस होगा, वहीं पे इंटेंसिटी ऑफ लाइट मैक्सिमम देखने को मिलेगी. दैट इज द पोजीशन. तो ये जो इनका कंस्ट्रक्टिव इंटरफेरेंस होगा, ये सिर्फ एक एंगल पे होगा जब इन दोनों रेज के बीच का एंगल 50 डिग्री बनेगा. When the angle was 50 degree, it means if this is the 50 degree, then what is the rest two sides angle? So the sum of these angles are 180 degree. So 180 minus 50 degree, it means 130 degree. Now this 130 degree is divided into two equal parts. इस डिटेक्टर को हम ऐसा, मीन्स इस निकल क्रिस्टल को हम ऐसा घुमाते हैं, ये आप याद रखिएगा कि इस निकल क्रिस्टल को घुमाते समय हमारा ये और ये एंगल सेम होना चाहिए. ये हमेशा सेम ही आता है. मीन्स दिस रेस्ट टू एंगल्स विल बी सेम एंड इन मिडिल वन विल बी डिफरेंट. सो इफ दिस इज द 50 डिग्री, सो रेस्ट टू विल बी सेम. इट मीन्स दिस टू विल बी 65 डिग्री एंड 65 डिग्री. मीन्स दिस एंगल्स विल फॉर्म 65 एंड 65. मतलब निकल क्रिस्टल को हम घुमाते ही ऐसा है कि ये जो इसके अगल बगल के एंगल हैं ये इक्वल बनते हैं. इन सच अ वे वी विल रोटेट. एंड 50 डिग्री ही वो एंगल था जिस पे इन लोगों ने इसके इंटेंसिटी को लाइट के मैक्सिमम देखा. नाउ हाउ वी कैन सेटिस्फाई दैट दिस इज द करेक्ट रिजल्ट? सो मीन्स दे हैव गॉट दैट 54 volt was the only voltage on which they have got the maximum intensity. 50 degree is the angle between the rays on which they have got the maximum intensity. मीन्स ये दो कंडीशंस थी, 50 डिग्री एंड 54 वोल्ट, जिस पे इनको मैक्सिमम इंटेंसिटी मिली. नाउ वी हैव टू सेटिस्फाई दैट आवर रिजल्ट इज करेक्ट और नॉट. हाउ दे हैव सेटिस्फाइड दिस रिजल्ट? सो फर्स्ट ऑफ ऑल दे हैव कैलकुलेटेड द lambda wavelength of these rays with the help of Bragg's law, that is n lambda is equal to 2d sin theta. So n यानी कि जब यहां से इस सीधे एंगल से इस क्रिस्टल को इन्होंने रोटेट करना शुरू किया, तो ये पहली बार ऐसा देखने को मिला जब इंटेंसिटी ऑफ लाइट मैक्सिमम थी. यानी कि पहली बार इंटेंसिटी इस पोजीशन पे मैक्सिमम देखने को मिली. इट मींस फर्स्ट n विल बी 1 वी विल पुट. नाउ 2 into d. हमेशा ये जो दोनों लैटिस लेयर बनते हैं एटम्स के बीच के लेयर, इनको ब्रैग लॉ में डिफाइन किया गया कि दैट सेपरेशन बिटवीन द टू लेयर्स इन अ क्रिस्टल इज d इज इक्वल टू 0.91 एंगस्ट्रॉम. इट मीन्स 0.91 d इंटू साइन थीटा. थीटा इज विच एंगल? थीटा इज दिस एंगल. इन एंगल्स को हम यहाँ थीटा लिखते हैं ब्रैग लॉ में. दोनों लेयर से जो रिफ्लेक्ट होके जाती हैं, इनके बीच का जो पाथ डिफरेंस है दैट इज गिवन बाय द थीटा, इट मीन्स 65 डिग्री. एंड व्हेन दे हैव कैलकुलेटेड दिस, when you will result you will calculate, then you will get 1.65 angstrom. This is the wavelength according to the Bragg's law. According to this crystal's Bragg law, the wavelength of this ray becomes 1.65 angstrom. Now if according to the matter wave, according to the de Broglie formula, if the wavelength of this ray also becomes same, it is also become approximately 1.65 angstrom, it means this experiment was correct. and इस एक एक्सपेरिमेंट को बहुत ही बड़ा सपोर्ट मिला, डी ब्रॉगली के फॉर्मूले को एक बड़ा सपोर्ट मिला, और पूरी तरह से डी ब्रॉगली के एक्सपेरिमेंट को वर्ल्ड वाइड एक्सेप्ट किया गया. और उनके डी ब्रॉगली के एजम्पशन को डेविसन और जर्मर और जीपी थॉमसन ने एक एक्सपेरिमेंटल प्रूफ दिया. इसके लिए उन लोगों को क्या मिला? They have got the Nobel Prize. It means कितना बड़ा ये एक्सपेरिमेंट था, you can assume. Okay, so now see how we will calculate the lambda. So lambda formula we all are knowing. We have discussed in our previous video lecture. The wavelength according to the de Broglie is what? D is equal to, means n is equal to d upon under root 2m e v. This is the formula to find the wavelength. Lambda is equal to d upon under root 2m e, where m is the mass of electron, e is the charge on electron, and v is the voltage. Now put d is equal to 6.6 into 10 to the power minus 34 upon under root 2 into m is 9.1 into 10 to the power minus 31 into e, charge on electron, we all are familiar, that is 1.6 into 10 to the power minus 19 into V is 54 volt, 54 you will put here. Now after the calculation, when you will do the calculation of this, you can do by yourself also, or not by this formula. You can calculate this lambda by this formula also, 12.27 upon under root V angstrom. By this you can also calculate this, we have also discussed. So V only you will put here 54. So after calculating this, you will get the result of lambda approximately 1.67 angstrom, the wavelength of the light. And now we have seen that yes, the wavelength in both the cases are same according to the Bragg's law and according to the Davisson-Germer experiment, means according to the de Broglie's hypothesis. Both the result of the wavelength of the emitted electrons by this setup are coming same. It means this experiment is 100% correct, and it has given a big support to the experiment of Davisson and Germer and the law of de Broglie hypothesis. So that's it in today's video lecture. Now we will discuss our next topic in our coming videos.